Hey you guys, Randy Richard in the shop. I've had some questions about balancing and specifically about grinding wheels. So I drew some pictures here, and in Machinery's Handbook. Now, my version of Machinery's Handbook I have here is a 17th edition, so it's kind of old. And there's just a little bit about balancing, okay, in it. Half a page or so. One page. Yeah, one page. In the newer editions, I have one that's online, and that has quite a bit in there. But what I'm going to just go over real quick so the way I do the balancing, and it seems to work pretty good. And this is just about static balancing, not about dynamic or running balancing, but static, because what we're balancing is a disc. So, grinding wheel. This is for the surface grinder, and this one's 7-inch, half-inch thick, 1.25-inch bore. Something thin. So, the steps I go through are this. When you first get your wheel and you put an arbor in, there may be some play. They may not have positioned that perfectly. But you know, this is a Norton wheel, and they make high quality stuff, right? But still, your arbor isn't the same as theirs. So you're going to put that in there, and that slides in. So there, I can feel a thousandths in there or so. You can even hear it. So there's a few thousandths play. So when I put it on my arbor, it is not necessarily centered or concentric, because I bet you that hole in this here is concentric when they made it. But when I put it on my when I put my hub in and mounted on my arbor, my hub, because of that play, my center of rotation is not necessarily the same as where that they were concentric with when they made this. So what you'll have is the center of your disc, like I said, the wheel. But when you put yours in, I'm going to draw this, exaggerated. So let's say it's off to one side. That distance that it's off is a lever arm, right? Let's say it's off to the side. So the weight of your wheel is not. Well, first, I'm sorry. Let's first talk about the concentricity, because of how what I do, because it's now off center, this is not going to spin true to my center of rotation. So what I'll do is I'll put it on the grinding wheel after I mount my hub. I'll put it on the grinder, and I will true it with my diamond. So I put my diamond on here, and I true my wheel. So now the OD is spinning true to my to the center of rotation. Right? Even though I had that lever arm, I still have that, but now at least things are concentric. Then you take it off, and then I balance it. So I still have this lever arm of weight, because I might have taken off a little bit more. Maybe I took off a little bit more off of this side when I trued it up than on this side. And so now I removed that little bit of extra material, so now I'm out of balance. So now I need to balance it, because it's all about center of gravity. If a perfect wheel, the center of gravity is right in the center. The gravity is pulling down, and it's right in the middle. But in an imbalanced state, the center of gravity would say it would be over here pulling down, and that's what causes your imbalance. So what you're going to try to do is how am I going to get that center of gravity to move back to the center? So first I trued it up Then I take it over to my balancing stand, which I'll show you in a second. And I'm going to find out where is it heavy. So if I had removed a little bit extra over here, obviously it's going to be over here heavy, and the wheel is going to want to rotate on my balancing stand because I have an Anderson one. You know, it's with rollers, so it's going to want to roll, and the heavy spot is going to want to roll down. So as I balance it, I find as it rolls, so it rolls down. So now this is my heavy spot, so I mark that. And then I need to remove some material. And what I've done is I took it's about a 1/2 inch drill, and I've ground a shallow angle and hardly any rake on it, and I drill some holes. I might drill only one small hole. You know, you got your hub hole, and you got your hub, and just outside of that is where I'll do it. I'll do it up near here, and I'll drill a hole, 1/16 of an inch or so deep. Not very big, not very deep. And then I take it back to the balancing stand, do it again, and do it again, back and forth. And you might end up with a couple holes like this. You know, 3, 4, who knows? It all matters how bad it is. And yes, you're weakening the wheel. This is a very common practice, and you know, you're not drilling too very deep, really. You're just at the 1/8 of an inch is going to be the maximum about your depth you really need to drill. And the farther out from the hub gives you more leverage, so you have to actually remove less material the farther out you do this. But the farther out you do this, the less working room you have with your wheel, because you'll have these holes. So I try to do it near the hub area, outside the cardboard. You know, I try to do it up in here. And as you do this, each time you mark as it rolls, it's going to it'll start to shift. And then you need to drill a hole there or the hole there, and you'll end up with maybe 3, 4 holes. Who knows? You know, hopefully not all the way around, because that will weaken it a lot. But usually it's just a few holes. Until when you have it on your stand and you spin it, pick one of your spots, and it will stop maybe anywhere. It could stop up here, it could stop over here, and after you do it 4 or 5 times, at least, it stops in different spots. You've reached pretty much static balance, and you've moved your center of gravity from out here closer to the center of your rotating disc. Now, imagine that's only a 1/2 inch, but that's like more than that, right? So you're drilling your holes over here like that. And being something thin, the lever arm from the center to where you've removed that weight is very short. And it's a very small amount that you might throw the disc off in balance in this way. Yes, you could. You could remove material from each side if you really want to play with it, but this is very hard to measure in a static balancing rig of the weight this way. So far I've only seen the need to do it from one side, but I've never noticed it otherwise. But if you want to go really accurate, drill once over here and drill once over here to maintain balance in this axis. Now, if you have a long piece of shaft or something where you've done some oblong turning, like a crankshaft or something, you know, you've done some turning where you've only taken off that much there, but over here you've taken off this much. You know, it's off center turned. Now that weight there is now not along the center line. The center of gravity of this section has pushed to one side. that could throw this shaft off and down at this end and not down here. So you could statically balance it. It might spin just fine. Especially if you have the same thing over here and a small thing here, where this pushed it off this way, it might statically balance fine. Yet this way, it's not balanced. So you have it might not be in the center this way as far as the length longitudinally, your center of gravity. It might be over here a little bit, and you need to find where the true center of gravity of this is and needs to be balanced to. It is not necessarily in the center. That's where a dynamic balance is what you normally need to do on something long that could be unbalanced. It might not spin well at high speed. But like I said, we're talking about grinding wheels and thin disc. So this is mine. Now it's got rollers, and these have all been balanced even. All these rollers, you'll see here, there's holes that have been drilled, small ones, big ones, to balance each disc. So even though these were machined, they might have been. They probably started out as castings. This one has a lot of holes. They might have been started out as castings because they have hubs, and so they had to balance them, and they wanted them to be fairly good. These have ball bearings in here that I've cleaned and I keep lubricated, and that thing will spin for minutes. It'll just go and go and go. So that's good. What I've done is I made an arbor. This arbor is, lengthwise. This is off center, so the balance of this is not necessarily in the middle this way, but it really doesn't matter. It matters that it's concentric. I turned it between centers so that it is balanced in the rotational axis. Let's see. We'll just take this one. This wheel here has a hub that you can it has weights. Now I've already balanced this. Now hopefully it's still in balance, but I haven't checked it lately. But it has weights you can move around your hub here to balance it instead of drilling holes. So this has the same taper as there. I just stick this on with a little tap, and then I just use a silicone rubber washer I made there to keep it in place. And you give it a little roll. Make sure these are clean. Hear grinding on something. Probably a little speck of dirt on there or something. I just take a Sharpie and I mark it. This wheel, it looks pretty. It's probably pretty good still. So I would then mark it. I'll roll back. So then I would mark it down here where I feel it's the heaviest, and then I'd give it a roll, maybe in the opposite direction even. And I do this 4 or 5 times so I can get a consistent idea of where do I really need to drill a hole or maybe change the weights. So we just did it a couple times, but I ended up with two marks 180 degrees apart. So this wheel is pretty balanced, if that's the case, right? So that one's, I have no problem using that one. All right, I just threw this hub in here. This is not really the cleanest of hubs, but well, and we haven't grounded or anything, and we're just going to see how it is. You can just see how it rolling up slow, and then it goes faster. So it's definitely, and then it's going to roll back. Definitely has a high spot or a heavy spot. All right, so it's almost stopped. I'm just going to do it for speed it up here. So we'll just put a little mark. We'll do it again. And that's so heavy though, it's going to stop at the same mark. There we go. Oh yeah, same spot. It stopped in the same spot both times. So there we would have to drill a hole there, maybe even two. It's pretty heavy, and then we just keep doing the process over and over. Once you're done with this part of the balancing and you're happy with it, then you're going to put it back on your surface grinder and redress the wheel and retrue the wheel. Now yes, you're going to take off a little bit. You're going to make it round again. But you know what? You're going to be very, very close to balancing. If you want, then you can bring it back over and rebalance it. So I did this whole process with this wheel, and I haven't touched those weights since. I mean, that's how you were talking very, very small amounts, usually after you true it, and then balance it, and then retrue it again. You should still be concentric, but you've removed the weight of where the imbalance was. You're always going to redress afterwards. You're not going to go right from the grinder and use it. I mean, right from the balancer and use it right away without dressing the wheel. Just in case it's a little bit different, because you've changed the balance of it. So you might have had a little wobble. And so you're always going to want to dress it that last time. So like I said, all I've done is dress this wheel. I've used this wheel quite a bit, and all I've done is dress it, and I haven't changed the weight since I put this hub in and balanced it. And as you saw, it's still in balance. So yeah, so you can make your own arbors. Now there's the other kind of balancers where the rails, and you roll your piece on your arbor along the rails, but you need to have you need to set up your rails and have them level. That's the only thing there. Here, this does not need to be set level. It works. I mean, my table here is pretty level, but they don't have, doesn't have to be perfectly level. Let me put it that way for this to work. I've never had a problem with it doing that. Anyway, guys, that's just a quickie. Thank you.